It's sort of just like the next generation of Microsoft Clippy.
As somebody that spent a while at Microsoft, I have to say, yes, it probably is. Clippy is coming back, and he's going to be bad.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Hello again, all of you wonderful How AI Happens listeners out there in podcast land. It's me, your buddy Rob, here with another classic installment of the show. But before we get to today's episode, some quick housekeeping to share with all of you. Two pieces of news to share, really. Piece of news number one is that our friends over at Sama recently published the 2023 edition of the Machine Learning Pulse report, where they surveyed thousands of practitioners in our space about the role of generative in their work, how they're measuring model effectiveness, and how they expect it to impact their work in computer vision. The report's a great way to kind of benchmark your own experience, maybe a little bit of a gut check to know that my peers are facing some similar challenges I am when it comes to measuring success, and also here's how they plan on dealing with it. Definitely check it out. There's a link to the report in the show notes. But that's not all. Piece of news number two is related, and that is that we are hosting a live webinar edition of How AI Happens on Tuesday, November 14th, to unpack the report. We have assembled a panel, including the Chief Science Officer over at Voxel 51, Jason Corso, who also, by the way, happens to be a professor of robotics and electrical engineering and computer science at the University of Michigan. Go Blue. And we're also going to be joined by the SVP of AI Products and Technology at Sama, one Duncan Curtis. They're both really smart, really technical guys, and they're going to solve some of the problems surfaced by folks in the report. They're going to share how they anticipate generative is going to impact our space, and then also taking all of y'all's burning questions. So if you get a chance to check out the report beforehand, anything that sticks out to you, we're going to make sure we save some time for y'all to interact with the speakers. So it would be a really good chance to get some advice from the folks out there who are really doing this at a very high, very technical level. If you have enjoyed what we're doing here on the podcast, the webinar next week is going to be a great way to engage, like I said, to have some live back and forth with the pros, and of course, hang out with me. We're going to just pack a ton of information into the webinar, and we're going to have some fun doing it. So the link to sign up, again, in the show notes. It is completely free, obviously. So I'll see you there. Okay, now, on with the show. Today's guest on How AI Happens is someone I am really excited about. He has been around the block a few times in our space. He was the Chief Product Officer for Artificial Intelligence over at Core Scientific until such a time as I believe they were purchased by his current employer, AMD, where he is now the Senior Director of AI Software. Ian Ferreira, welcome to the podcast. How are you today?
Good, Rob. Good to be here.
I'm so pleased you're here and that you went the distance and going so far as to steal your son's video game headset because that was the best audio option. You had to snatch it out of his hands and say, "No Gran Turismo, buddy. Dad has to do a podcast."
That's exactly right. The agony on his face because he was in the middle of a game. But, we do what we do.
Sorry, bud. If you want me to keep playing for that PS Live, I gotta do my job.
I gotcha.
Oh, too good. I shout out to your son for being understanding. And anyway, I'm really, really glad to have you here. And did I do your curriculum vitae justice or anything else from your background? Maybe you can add to sort of set some context here.
Absolutely. So as you mentioned, I joined AMD just over a year ago as part of an acquisition. I've been in the ML infrastructure space in the startup circuit specifically for about 8 years. And I spent just a couple of months shy of a decade at Microsoft before that. I'm originally from South Africa, so that explains the weird accent. And right now I lead the AI software solutions team at AMD, and our primary goal really is working with customers to onboard their workloads on AMD Instinct GPUs.
So your career has kind of taken a a somewhat familiar trajectory in terms of how you wound up getting to AI. You had been a software engineer, sort of climbing the ladder, program manager, data science, all these various skill sets. At what point in your career did AI become your focus?
That's a great question. I, like actually a lot of people in this space, started in the machine learning area, specifically in ad tech. So you would notice a lot of the people in AI have an ad tech background. And arguably, that was the first large machine learning production workload in search, which was click prediction. And a lot of the big data technologies came out of ad tech. So I've been adjacent to it pretty much my entire career. It was used for something much less noble than ChatGPT in serving ads, but we at least developed some of the technology. I think my focus specifically on what today, is called AI is when I left Microsoft and joined a framework team that were training large models on accelerated software stack. And the pitch the guy gave me when he lured me away from Microsoft was something that used to take 24 hours on a data center can now be trained on your laptop. So it sounded very compelling. It turns out it was just an early version of Spark. But, it got me going, and it's just remarkable, the potential of AI. And so now I'm fully in it. I think it's a game changer.
A moment ago, you said that ad tech is much less noble than ChatGPT, which for me begs the question, is ChatGPT noble?
A good one. I think it's more so, well, maybe not ChatGPT. I mean, let's put that aside. I think the idea of serving ads and the amount of technology that goes into just picking the right ad is almost embarrassing in a certain extent. And if I could do things over, I probably would have switched careers sooner. But ad tech was great for me. I rode the ad tech wagon all the way from South Africa through New York into Microsoft in and around Bing. But, I think there are significantly more noble applications in advertising for AI. And ChatGPT was great in that it put a face on AI. For a lot of people, they couldn't really get their heads wrapped around, okay, so what is this AI and how is it real? But actually having a conversation with something that's not a person and passing the Turing test, I think that changed the game. So I think from here on, we're going to see a lot of changes in how we work and live based on large language models.
Do you think that sort of demonstration to the masses, let's call it, of what AI kind of is and something that people can wrap their head around, do you think that is perhaps more meaningful than just the possibilities with LLMs or ChatGPT specifically, or is it, just different sorts of applications?
No, I think it was the Euro app for sure for AI to date. And that created a lot of investment. That combined with the study that Microsoft did around Copilot and the 50% productivity. So you imagine if you're a CTO or CIO, you're thinking, wow, I can shave 50% of my R&D budget by using CodeGen or Copilot. I think that's a game changer. I think the actual use case of LLMs will develop and evolve. I use ChatGPT a lot more in the beginning. I think it will weave its way into products more seamlessly. Instead of being a destination where you say, okay, I'm going to go to ChatGPT, I'm going to ask it to do something. It'll be woven into your email client and to your presentation client. And so I think that makes it more natural than a destination where you have to go and do things. But at the same time, we're at, at 10 trillion parameters. Next one will probably be 100 trillion. And I think that's when you'll start seeing really scary reasoning capabilities coming out of these large language models.
Scary how?
I think just scary, unpredictable. I'm still blown away that, if you think about the model architecture behind transformers and ChatGPT, it's a very, arguably a very simple model. And the idea that something that essentially builds a massive graph between words and sequences can actually semi-reason and sound intelligent, it's quite remarkable. I don't know if I should be depressed as a human that I can be mirrored so easily or impressed by the capabilities, but I think it's definitely mind-boggling, the capabilities that come out of that transformer network architecture. Are we really just a bunch of connections, right?
Yeah. I mean, a bunch is like a lot, but a finite number, it turns out, right?
Right. Exactly.
So the Copilot trend, I think, is pretty well established. So we're going to see like an LLM sort of assistant in lots of different sorts of softwares. What about the possibility for ChatGPT or whatever, its next iteration, its next competitor, to replace our standard conceptions of search?
That's a good point. So, just if you look back at some of the tech-defining moments of our civilization, I don't want to get too philosophical, but the industrial age, the invention of machines changed a lot of the blue-collar lives, right, and how things are made and in factories. We're now in the digital transformation era, and AI is in the middle of that. And I think it's going to be impacting more of the white-collar workplace as much as the industrial did blue-collar. And I think the typical knowledge worker careers are going to be very impacted. I think it's going to start with augmentation. But a lot of what we do as humans is pattern recognition, is researching. So if you kind of build that forward to search, I don't think that the search index is going to go away. I think that there's still place for structured data, and not everything has to be weights in a large transformer network or a mixture of experts networks. I use the analogy, even as a person, I can give you a document to read, and then I can ask you questions after that, and you can reason on it. So in a way, it's like pre-prompting or RAG, retrieval augmented generation, versus having that trained into the model a priori. But I think there's definitely going to be a lot of use cases of augmenting enterprise search, so taking data that's locked into relational database managers, into other enterprise search products, and just using an LLM to put almost a friendly veneer around it so that I can reason on data that before I need to know how to write a SQL query or how to work SharePoint search. And, a lot of skill with search is really typing the right keywords. But an LLM allows you to have a natural conversation with the search agent, so to speak.
Yeah, definitely. It's sort of just like the next generation of Microsoft Clippy.
As somebody that spent a while at Microsoft, I have to say, yes, it probably is. Clippy is coming back, and he's going to be bad.
Don't call it a comeback. Clippy is back with a vengeance.
Yeah, exactly.
Clippy's origin story is you swearing at him and Xing him out every time you opened up Microsoft Word. Did you work on Clippy at all, Ian? I'd be so tickled if you did.
No, I was after Clippy, but I did use it as an end user. I remember the fun at every time you'd print something, its eyes will go into a little box, like it were really cool animations.
That's right.
I was really rooting for Cortana personally. I wish Microsoft will bring Cortana back as the face of ChatGPT instead of Clippy, but in any event, it was a good time. I had a lot of fun working there.
Yeah, good. Well, we sort of jumped in the deep end here, Ian, because, we were getting a little carried away, but there's nothing wrong with that. However, I do want to make sure that we learn a little bit about what you're working on right now. I guess, first of all, when I think of AMD, I think of hardware, I think of GPUs. You're the director of software. Mm. So I guess I would just love to know a little bit about how you conceptualize your role.
Yeah, so my role is really working with customers on moving their workloads onto AMD infrastructure. And so that's a hardware and a software story. And I think we have a very differentiated product in both categories. So if you look at the hardware side, AMD has a broad portfolio. We have really killer CPUs with Ryzen and EPYC. We have GPUs with Instinct. We have gaming GPUs with Radeon. And then with the acquisition of Xilinx, we have FPGA. So it has a broad sweep of products from cloud to edge or edge to cloud, whichever way you want to go. And so that makes a lot of end-to-end workloads and scenarios possible. But what really makes the difference, speaking as a software engineer, is the software stack. That's ultimately where the rubber hits the road, where hardware becomes something useful, is in the software layer. And I'm not just saying that as a software guy, but that's definitely the milestone that you want to achieve. With AMD's software stack, the team did a great job in making it very interoperable with existing workloads. So instead of saying, hey, we're going to make it different, it's very similar to how you might use data scientists might use their PyTorch, their TensorFlow, their JAX today. So there's no additional work. There's no, now I have to change it to run on AMD. Now I have to change it to run on the other guys. And that makes a huge difference. The other big differentiator is open. So all our stuff is open source. AMD has a strong ethos both in open source and in partnerships. We don't compete with our customers. And so being open allows you to go and look at all our code and make sure that whatever you're going to deploy is something that you've looked at. We talked about how easy it is to take workloads that you've run on PyTorch or TensorFlow or JAX and just run them on AMD. That makes a big difference, especially if you're the IT manager and you're thinking about adding AMD GPUs to your cluster. You don't want to have your customers yell at you and say, oh, my stuff's not running, blah, blah, blah. So from that point of view, the team did a great job. A little higher up this, actually, we talked about the frameworks, TensorFlow, PyTorch, JAX. We have a great partnership with Hugging Face. Hugging Face, did a phenomenal job in democratizing transformers and diffusion models. And so we've integrated with them over 60,000 models are CI/CD, so basically validated and QA'd every night. So that's a super big set of their models. Of the 60,000 are running on AMD. And that makes it possible for somebody to go into Hugging Face, copy paste a code example and plug it into a notebook that's running on AMD, and it'll just work. And I have evidence of this because I showed a salesperson how to do that and they were able to do it. So there you go. And then we also recently did the acquisition of Nod.ai. So really smart team, a lot of experience in low-level graph compilers. And so we expect them to use their expertise to make our software story even more performant, to make it even more adaptable to our own different hardware endpoints. So a lot of good stuff happening in the software space. And that, I think that's going to be important for AMD going forward.
It seems to me that GPUs, having them at all, right, and then being able to kind of rent access to them is sort of an arms race, is sort of a negative connotation, but it does feel like that's kind of what's going on. Would you agree with that characterization?
Yeah, I think this is one of the things that happened with LLMs, right? So the amount of GPUs needed pre the LLM phase were hundreds or tens of GPUs. And, you would be like the king of the hill if you had 16 GPUs. And then LLMs came out, and all of a sudden the scale went to thousands and tens of thousands of GPUs. So that put a lot of pressure on the supply chain. It's people are buying enormous amounts of GPUs to train these models. So I think that made a big difference. I'm still blown away at the size of some of these clusters that are used to train these models. It's mind-boggling how big these clusters are, the amount of networking technologies that's involved to get these, thousands of GPUs to work together. It's a pretty amazing feat.
Is that strictly necessary? Because what I tend to hear, particularly from data scientists, is use the right data. It doesn't necessarily need to be like the more, the better. Let's try and be a little more efficient. When you see some of these huge processes, right, with all of these clusters utilizing however many hundreds, thousands of GPUs, is that always necessary? Is there a bloated nature to some of that?
I think it's more of a case of separating the workloads and use cases for the end customer. So if you're in the foundational model game, right? So if you're one of these few companies that train these large models from scratch, you actually don't have a choice. You're stuck with having to have clusters of tens of thousands of GPUs, especially when you're going north of the 100 billion mark. But if you're an average enterprise and you're looking to what's called fine-tune a model, so you take one of these foundational models and then you tune it for your specific domain, then yes, of course, you don't need the same size as the pre-training ask. But there's a paper that shows that provided you have enough data, right, because you can't just have compute without data. If you have enough data, you can keep growing the model and it will get better. And so that's what this quote-unquote arms race is, which is, who's going to be the first person to do a 10 trillion and then 100 trillion model? Because we really don't know what's going to happen in terms of reasoning capabilities at that next tranche and at the next tranche. So I think those type of customers will need GPUs in the tens of thousands. The average customer that's doing fine-tuning in their enterprise or doing enterprise search, they will probably have a different scale point.
Are you allowed to say which customers those are that are doing those huge processes? Or how about just like an industry?
No, the foundational model experts, right? So OpenAI, the Microsoft, everybody that you see talking about creating their own LLM. So Mosaic, for example, created an LLM to up to 30 billion. We're actually working on a project with Allen Institute. They're creating a model. Right now, they're doing a 7 billion parameter model on one of our partner supercomputers in Finland called Lumi. And the next tranche is a 70 billion parameter model. But again, this is still small when you think about what Microsoft did or OpenAI did with their 1 trillion parameter model. And so I don't know, maybe ChatGPT 5 is 10, maybe ChatGPT 6 is 100 trillion. I don't know, but it gets up there, and it's going to be interesting to see the capabilities of these models once you get to those many nodes.
I'm glad you brought up the Allen Institute, because you have this partnership where you are sort of providing your own open source LLM here, where you are taking advantage of AMD's open source approach. You mentioned that a little bit earlier too. I would just love to hear you share a little bit more about that, of what that entails, how customers are using it, and why that decision was even made.
Right. So we typically have a history around working with researchers in the scientific domain, both, on the traditional HPC side with the national labs, etc. And so this was a partnership with Allen Institute. And the key differentiator is everything is open, right? So the licensing model of the model is open. It's not restricted. The data that was used to train the model, usually that's kept proprietary. That's also open. It's called DOLMA, DOLMA, and the model is called OLMO, OLMO. And so both of these are open. The source code, actually the code to train the model, is also open source. So I think the intent is just to give the scientific community a fully open source solution trained on AMD with some models that they can start with and then fine tune. So if you want to start with a 7B model and fine tune it, or early next year, the 70B model and fine tune it, you can do that. And you don't have to worry about some licensing clause buried somewhere in the T's and C's in how you use it. The data sets they're using are 3 trillion tokens, so it's pretty sizable. And it's funny, when we started this project, we had scoped it to a specific size. But then the industry is moving so fast, it's like, well, 2 trillion tokens isn't that cool anymore. You need 3 trillion tokens. And so as we're going along training these models, we have to kind of pivot and adjust to make sure that it's still state of the art when we come out the other end. But what's remarkable is it's all happening on AMD infrastructure.
When you talk about the need for trillions of tokens or thousands, hundreds of thousands of GPUs, it makes me worried that there is sort of this privilege to be able to use that many GPUs. Like you have to have some pretty serious resourcing to be able to do that sort of processing. Is there any mind being paid to the folks who certainly cannot afford, to rent that many GPUs or to use that sort of infrastructure, but still have worthwhile projects?
Yeah. So Olmo project is one attempt at this to make a pretty sizable and pretty powerful model available to the general public or whoever wants to use it. But I think the meta point is true. There is a have and have-nots of hundred thousands of GPUs. And to make it even more complicated, there's this aspect of countries wanting their own sovereign models, right? So we're seeing a lot of countries in Europe wanting to train their own models in their own country. And so now they're trying to find out, well, where am I going to train these large models? Where do I have GPUs in the tens of thousands? And I think that's going to continue, because if this all pans out and you end up with something that's so powerful, do you really want to have a dependency on another country or one specific company to provide that service? So we're seeing a lot of sovereign language models spun up. There's obviously the case of models trained on specific languages. So, for example, in Finland, on that same Lumi supercomputer, the Turku NLP University, they trained a Finnish model that was 13 billion parameters. But that's just one example, right? You're not going to find a Finnish model unless you're in Finland, most likely. And you're not going to find Japanese models unless you're training it for the Japanese market. And so just pure by language, you're going to get some segmentation. And then because of the sovereign risks, I think you're going to have models being trained in country.
So that governments will have to fire up their own native versions of AMD, basically.
Right. They'd have to find some infrastructure. So that's in Europe. They're basically using the supercomputing centers to train sovereign models right now. And I think that'll continue.
Can you explain what you mean by sovereign model?
It's basically a model that's trained in country for that country and using the country's data. So there's no import or IP issues, if you will, as the IP moves across country borders. That's a data governance, if you will, could be another way to describe that.
Gotcha. Isn't that the case too with any like sufficiently large organization though, that they would be sort of defending and a little bit hesitant about handing over data?
Exactly.
I guess higher stakes though if you're a government, I suppose.
Yeah, exactly. And the one of the funny things, which is why it's important to see the data, is what data goes into this reasoning engine, and does the people that created that data have any claims to the capability of that reasoning engine? So there's a lot of those conversations happening around generative AI as well. So knowing what data was used to train the model makes that a non-issue.
Right. That's explainable AI, no?
Exactly, yeah.
Well, Ian, we are creeping up on optimal podcast length here. This has been a blast. Before I let you go, though, I wanted to ask about this event that AMD has coming up here in the Bay Area early December. Would you mind sharing a little bit about that?
Yeah, so Dr. Lisa Su is going to be talking about some new product announcements. It's called the Advancing AI event. It's December 6th in the Bay Area. I'm really excited, not just as an AMD employee, but as an AI practitioner. I think the partners and customers that the world will see will be impressive, and I really, really look forward to it. I think it's going to be phenomenal. I'm super excited about it.
So I'm sure you can't spoil too much, but is there anything you can share about the nature of these announcements?
No. I think I think the attendees and audience will be impressed with the progress AMD has made. I think, unfortunately, a lot of the progress we've made was in forums that we couldn't talk about. And so being able to actually come on and show and talk about the work we've done to date and, be able to openly talk about it, I think that's, for me, is the biggest excitement.
Yeah, and just kind of what I can tell from the website and sign-up page, it looks like you're going to be telling some stories from some of the cool things customers are doing and sort of getting under the hood and seeing some of the cool work going on over there. So
yeah,
I will be tuning in for sure. I believe there's a live stream, so I'll try and put some kind of link in the show notes for people. They can bookmark it. They can come back when it's time in early December for that announcement. Until then, Ian, I got to say, this was really interesting. So thanks for coming on and chopping it up with me and getting a little philosophical. I really do appreciate that. Great having you here.
Fantastic. Thanks so much, Rob.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI, specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.